And there are some products out there, felt paper being one of them, that is not a Class 1 air barrier. Now, how many of you are familiar with AVA? Why don't you pass these down? Recently, as of 2 months ago, not only has our fluid applied been AVA qualified, but both our commercial rep and commercial rep D has been AVA qualified, which means we are one of the only wraps out there now that has been AVA qualified to meet their standards, which means it'll meet ASHRAE 90.1 or 189 for air infiltration resistance and water program. But if you were to take Tyvek and look at it under a microscope, it looks like that artificial spider web you see around Halloween. And so it's it's tightly woven poly pellets that have been gone. I wish we had slides to show you what the process is, but it comes out and it shoots together. It was actually discovered by accident. They were actually working on something else and a pipe burst, and then they came out with this product, and they sat on a shelf for years before they figured out what to do with it. But what it does is it allows vapor transmission, okay? So to infiltrate and exfiltrate. So the photograph on the right shows you a piece of Tyvek over boiling water. You can see that the vapor is exfiltrating to that. Yet at the same time, it's tightly woven enough that it keeps out the water. Okay, and so that gives it the balance of properties when we talk about air and water holdout, but also vapor permeability, which anything is considered to be vapor permeable if it rates over 5 tons on the ASTM scale. In some cases now they're saying that it should be 10 tons. But what Mark has here, he's going to tell you.
We've got a really highly scientific test here that we carry around with us, but for years we've taken just mason jars, and you can put a sample of a competitive house wrap on there, and put a little water in there, put a piece of Tyvek on the same type of jar, and it's pretty good example of how it stops water. But if you were to leave this sitting out on the table for a little while, eventually all that moisture would evaporate through it. So
that's when we talk about that Tyvek has a balance of properties, whether it's our sheet goods or it's our fluid applied. So it resists bulk water, wind-driven rain that gets behind the cladding. It resists air infiltration, air penetration and infiltration and exfiltration that allows moisture vapor to pass through. To understand moisture management, we need to examine the basic principle at work, and that's just the 4 Ds, which is deflection, drainage, drying, and durability. Walls designs that properly detail claddings, flashings, and so on will allow for that. So you want to make sure that if water gets through, it's stopped, and that it's deflected and drained down through a proper system utilizing through wall flashing and so on. What we're seeing now is, have y'all run across any projects that are using the exterior continuous insulation?
Oh, the Dow total wall kind of stuff?
Yeah.
Yeah, a couple.
Yeah. And so, what they're coming out with that is, well, let's use exterior rigid foam insulation on an exterior building, especially if it's metal studs, to help stop thermal bridging. And it does that. But it doesn't always still allow for how you're going to handle bulk water infiltration or how you're going to handle air infiltration system, because it's not proven to us yet that you can get a continuous system using that will allow for it. So we still believe that even if you were to have foam behind that you should still use a weather barrier either on top of it or behind it, depending on what the wall assembly is. So deflection is that means proper overlap and shingling of the system. That's important. And you notice we say systems approach, because it's not just the Tyvek itself, it's all the parts and pieces that make it a system that need to be shingled properly, integrated properly, the right type of fasteners need to be used. And when you do all of that, that's going to help with the deflection and drainage. The claddings are basically your first line of defense, and so when you install a good weather barrier behind that, you're going to get a secondary line of defense, in some cases a tertiary line of defense. Drainage provides a path for bulk water to exit the wall system and prevent potential damage.
we've been on a lot of jobs where the wrong type of product was used, and the OSB is starting to rot out, or water's gotten inside and the drywall is rotting. And to repair that, they've got to go in and declad it and take everything off, all the exterior sheathing, and replace insulation and everything else to repair it properly. And of course, the vapor permeability is just in that building drying out. You never want the wetting rate to exceed the drying rate inside that building envelope, because that's when you have potential problems with condensation, and then you get mold and mildew and rotting of wood, corrosion of metal. So vapor permeability, which again is any product that rates over a 5. In most cases, they like to see it rated over a 10. And they've said now that if you fall below a specific geographic line in the United States, that the building should be designed for vapor permeability. That's why a lot of products that you've seen, even on the boilerplate side, have started out with real low perms, and now you're seeing them, and also with the peel and stick or self-adhered, you're starting to see them come out with products with higher perm ratings, and that's because they finally understood what the building scientists are talking about when it comes to vapor permeability being important in the weather barrier. And then you want it to be durable because you want it to last. So, for example, on a 4-story commercial building, steel studs, exterior Dens glass, you wouldn't use a residential type product. Number one, you only get 4 months UV resistance with a residential product. With a commercial product, you get 9 months UV resistance. And number two, as you'll see when Mark talks about the products and hands them out, the commercial products are a little bit thicker mill thickness, so they're going to stand up to other construction trades better, and they're going to stand up to the wind pressures a lot better when properly installed. And so you want it to last, and especially before the cladding gets up. You don't want it to be exposed for over 4 months and having used the wrong product. So here's the balance of wetting versus drying. On the prevent wetting side, it's important to stop bulk water, air transport. And the reason you want to stop air transport is also if air infiltration gets in, it's bringing in water molecules. And if you don't have the vapor permeable design, that water gets in there and then it doesn't have a way out when the vapor drive changes. And so diffusion is the least of your problems on the wetting side. But on the drying side, in addition to ventilation, diffusion is your greatest ally because it helps that building dry out and it ensures that the wetting rate won't exceed the drying rate. AVA says that air barrier requirements are that it has air infiltration resistance, and that's basically like the Azure 90.1 or 189 that needs for the material itself or the assembly, or in some cases, the whole building. The Army Corps of Engineers is a higher standard than Azure 90.1 or 189, and they only do it for the whole building, and they want to pass that whole building blower door test. And we have shown that with proper installation of our product on a couple of different cases where they've done some barracks outside of San Antonio and did blower door tests, that we were able to achieve that better than what their performance requirements are. But also says it has to not only have air infiltration resistance, but it has to be has continuity. So it needs to be a full systems approach. And then there's that strength and durability that we talked about. That's important. So when you're doing commercial projects, you want to make sure you're using the right products. And that's why, as we passed around our products, Commercial Rep and Commercial Rep D, we're able to go through the testing and achieve the results that AVA is looking for and get there qualified. These are just some of the consequences if you don't stop air infiltration. It affects your thermal comfort, your air quality, because air infiltration gets into the building. It brings in mold and mildew spores and all kinds of stuff. And if you're not stopping air infiltration, there's been tests showed that through simulation, the Department of Energy commissioned this to do a study showing that you guys say it's important to use an air barrier. Why? And they said, well, it'll help improve the energy efficiency of your HVAC systems. I said, okay, prove it. So they took several different building types in several different parts of the country, and they established a baseline, a delta of what the energy performance was of that building before the installation of an air barrier. So they determined what that delta is, then they went back into simulations and installed air barriers, ran those simulations again, and they were able to prove that in some cases they could save up to 40% in energy costs. And of course, then it leads to the next one, moisture damage. So that which directly affects durability. And then when I was talking about this simulation they ran, energy efficiency. Air infiltration, there's a certain amount of conductive loops within inside the building envelope, but if air infiltration gets in, it speeds those conductive loops up, and that creates this wind washing effects, which drives moisture into the insulation. As insulation gets wet, it lowers the R value of that building envelope. And so you want to stop all of that. And so at this point, I'm going to turn it over to Mark. And are there any questions up to this point? Did I completely bore you, put you to sleep with building science? Or put me to sleep sometimes?
No,
So I
building-
drink a lot of coffee.
Yeah, building science is always exciting stuff, so.
Now we're going to get into the meat of why y'all are here, and Mark's going to.
Yeah, I'll talk a little bit about the different products we've got. I've got some residential products with me too, so, we'll just we'll cover all of our products, kind of talk about why, why use commercial wrap over a residential wrap for commercial construction. So, let's start with residential first. I'm going to pass around a little sample sheet here of Tyvek home wrap. Home wrap, again, this is the original, as Frank said, it's the original house wrap ever created. So 1978, not much has changed with this product over the years. They've added a little bit of basically sunscreen to it to protect it from UV exposure. But for the most part, it's the same product from 1978. So prior to this, all you saw was felt paper for the most part, if anything at all. So this product's a thinner mill than commercial wrap. You can leave it exposed to the UV for 4 months. It's 120 days max on this before you have to cover it up. And just a lower, I guess a lower story building, a smaller building where you don't have the higher wind pressures, because it's not going to have the same tear resistance, wind tear resistance that commercial wrap will have. But easy way to differentiate that product from commercial wrap is just the logo itself. We'll always have home wrap or commercial wrap. All of our products are stamped with the appropriate logos. So,
Can you put it on backwards? Does it work both ways?
that's a good question. With home wrap, you can put it upside down, inside out, frontwards, backwards. It's not a big deal. We'd love to see it, straight up and down like that's a great billboard for us, But for the most part, this product works the same way. There's no front or back to it, upside down. Now I'll talk about stucco wrap next. That is pretty critical in drain wrap or commercial wrap D, which requires it's installed a certain direction. But here's a sample of stucco wrap. So stucco wrap and drain wrap are the same product. You may hear some people call it drain wrap, some people call it stucco wrap. The difference between stucco wrap and drain wrap is the logo and then the roll size. So drain wrap's going to be a 9 or 10 foot roll, and then stucco wrap's always a 5 foot roll. Stucco wrap's been around since early 90s, I believe. Really created for the Southwest market. So, Arizona, New Mexico, Southern California, a lot of stucco out there. And they chose a 5